Welcome back, geometry students, to another Regents review video. These will be the solutions to parts 2 through 4 to the June 2015 Geometry Common Core Regents exam. This video is going to take a while. The part 2s, 3s, and 4s of the geometry Regents are really in-depth. If you looked at my other videos for Algebra 1 and Algebra 2, the answers are usually quick. The geometry Regents is really in-depth, so it will take a long time. So please just bear with me, be patient, and I promise we'll get through all the answers as quick as I possibly can. Okay? If you are here to cheat off of this video, please refrain from doing so. Once again, I'll say this every time, the geometry Regents is tough. Please try the questions on your own and then come here if you need assistance, because I'm always here to help you. If you did it, great, you're here to check your solutions, fantastic. Or you want to see how you did a problem, yeah, I don't know how to do that one. You came to the right place. So what we're going to do right now is we're going to jump right into the part 2s, 3s, and 4s. These are the open-ended response questions on the geometry Regents. Without further ado, let's get started. By the way, I will be looking to my left, which you'll see on the video, to your right, to make sure that I'm doing this correctly, and my notes are over on my left. So just keep that in mind if you see me look over here. Now, question 25 says, use a compass and straight edge to construct an inscribed square in circle T shown below, and of course leave all construction marks. So you need to know the steps on how to construct a square inside of this circle. So the first step that you need to do is you need to draw a diameter. Okay? That's the first step that you need to do. The second step that you need to do is construct the perpendicular bisector. Then the last thing that you need to do is connect the vertices, or the points. Now, why am I telling you these steps? Well, we're going to go more in depth as to why that is right now. So the first step that we are going to do is we are going to construct a diameter. You need a compass and a straight edge, and a straight edge is really just a ruler, so it doesn't matter what you have, but you need a straight edge first. So I'm going to construct a diameter all across the way. There's my diameter. Now, I need to create a perpendicular bisector, and this is why I'm doing this. In a square, by definition, the diagonals are congruent. The diagonals bisect each other, and the diagonals are perpendicular to each other. So I need to create the perpendicular bisector. In order to create the perpendicular bisector, you move your compass a little bit more than halfway of T, and you construct your first arc. Then you repeat the process on the other side without changing your compass setting, and you repeat the process on this side. Now, once you have these two arcs, now you could just take your ruler or your straight edge and you just connect these two intersection points and you draw your line. Okay? Now, these points that you see up here, these 2 points and these 2 points over here are the vertices of your square. So now you just take your straight edge again and you just connect all of those points to create your square. All right, so actually, you know what? I'm just going to use a straight tool. So there's 1, there's 2, there's 3, and there's 4. And that, ladies and gentlemen, is your square. Now, you could skip the next section portion of the video if you got this construction. The next section of the video shows a more hands-on construction. It actually shows me doing the construction by hand. So you could skip the next section of the video if you want to, but if you want to watch, go right for it and just keep watching the video. And if not, just skip ahead to question number 26. All right, so here is number 25 from the June 2015 Regents exam, and this is the construction. So the question says, once again, use a compass and straight edge to construct an inscribed square in circle T shown below, and of course, leave all construction marks. So this is just for people who do not like the computer software that I use and just want to see more of a hands-on construction. So the first thing that you need is, of course, a compass, and you need a straight edge. We are trying to construct an inscribed square. So the first thing to construct a inscribed square is to draw yourself a diameter. Remember that a diameter has to pass through the center of the circle and touches both ends of the circle. From here, we are then going to construct a perpendicular bisector. Now remember, on your compass, you have to measure a little bit more than halfway past the midpoint of your diameter. So I'm now just going to take my compass and swing it one way, and then I'm going to repeat the process on the other side. And there I have my two arcs that I need. From here, then you just take your straight edge and you connect those two intersection points, and there's your perpendicular bisector. And the reason why we're doing this is, remember, in a square, the diagonals are perpendicular bisectors of each other, and these are congruent because they're both diameters. So now we just connect these points. Now, once again, you take your straight edge and you connect all of these points to create your square. Now, if you made your square a little different in terms of the orientation, that's fine. That's perfectly fine. But I usually do it like this. It is on a slant, but that is still a square. All right, question number 26. The diagram below shows parallelogram LMNO with diagonal LN. The measure of angle M is 118 degrees, and the measure of angle LNO is 22. Explain why the measure of angle NLO up here is 40 degrees. So they're telling you immediately that this is 40 degrees. Now, in order to get this question right, you really need to know your properties of a parallelogram. This is a parallelogram because I tell you that. Now, when it says explain, you need to use words, actual words, to explain your answer. So this is what I put as an answer. I always begin these questions by as shown in the diagram. As shown in the diagram above. Parallelogram LMNO is drawn. Okay? Where the measure of angle M is equal to 118 degrees. That's just given to us, so we just need to restate it. The next thing that I'm going to say is this. In a parallelogram, the opposite angles are congruent. Therefore, it can be concluded that, zoom out here, that the measure of angle O is equal to 118 degrees. Well, why do I need that to be 118 degrees? Well, your goal is to say, hey, wait a minute. Isn't this a triangle? Of course it is. And in a triangle, there's 180 degrees. So if you're given two angles of a triangle being 118 and 22, we could solve for the third angle by subtracting those two from 180 degrees. So now the next thing that I'm going to say is that triangle LON is shown. That's the triangle that I highlighted above. Is shown where the measure of angle LON is equal to 22 degrees. In a triangle, there is 180 degrees due to the triangle angle sum theorem. All right. Now, I did all my word explanation. Perfect. Now I could use a little bit of math. You know, a little math can't hurt. I just explained everything in words. Now let's go into the equation itself. So now what I'm going to do is I'm going to say 118 degrees plus 22 degrees plus x is equal to 180 degrees. Why am I doing this? Well, this angle up here, which is your 40, that's going to be our x. We're just proving that it's 40 degrees. So now I'm just going to go back down here and continue my process. So 118 and 22, that's equal to 140 plus x is equal to 180. Subtract the 140 on both sides. You get x is equal to 40. Therefore, the measure of angle NLO is equal to 40 degrees. And that would be your answer. By the way, those three little dots there, that means therefore. And you'll learn that in college if you take mathematics in college. All right, that's question number 26. That's a really in-depth question. Let's move on to question number 27. The coordinates of the endpoints of line AB are A, -6, -5, and B, 4, 0. Point P is on AB. Determine and state the coordinates of point P such that AP to PB is 2 to 3. Okay, now listen. I teach this very differently. Your teachers could teach you... most teachers teach you to graph it on a graph. I don't do that. I do everything algebraically because that's just how my brain works. So, I'm going to give you two formulas that you need to memorize for your Regents if you want to do it like this. I'm going to show you both ways. I'm going to show you my way, and then I'm going to show you how to do it on the graph. Okay? So the formula that you need to know or memorize is x minus x1 over x2 minus x is equal to the given ratio. What this formula does is it will generate your x value of point P. And we have y minus y1 over y2 minus y is equal to the given ratio. Now, these equations have nothing to do with each other. They're separate. You solve them separately. They have nothing to do with each other. They just look very similar. Now, what this does is it sets your coordinates in a ratio to generate your values. So it's very important to understand this. It says AP to PB. Point A is the point that you always start with. You're going to call that x1 and y1. Your point B is always x2 and y2 because that's the last point that follows it. Now, I'm going to plug in my values. So x minus a -6 over 4 minus x is equal to the given ratio. Now, the given ratio is 2/3. 2/3 as a fraction is 2 over 3. You have to write it as a fraction because your goal is to cross multiply. Now, we can cross multiply these. So we have 3 times x plus 6 because 2 negatives give you a positive is equal to 2 times 4 minus x. Now we're going to distribute, and distribute. So we get 3x plus 18 is equal to 8 minus 2x. I'm going to add the 2x on both sides, and I'm going to subtract the 18 on both sides. Oops. I'm going to subtract that 18. So the 2x's cancel and the 18's cancel. I then get 5x is equal to -10, and then when you divide by 5 on both sides, you get x is equal to -2. Okay, so that's your x value. Now let's go ahead and solve for the y value. So we have y minus -5 over 0 minus y is equal to the given ratio of 2/3. We're now going to cross multiply. So we get 3 times y plus 5 is equal to -2y because that 0 doesn't do anything. I'm going to distribute that 3. We get 3y plus 15 is equal to -2y. I'm going to subtract the 3y on both sides. Then we get 15 is equal to -5y. And then we divide by that -5 on both sides. And you get y is equal to -3. All that work for 1 point. Yeah, 1 point. Because the question's saying state the coordinates. So all you need to do at the very end is just say, hey, point P is a point -2, -3. And you are done. That's how you do that question. Now, if you don't like it that way, I will be more than happy to show you how to do this on the graph. I'm going to expand this all the way out. That looks really gross. Hold on 1 second, folks. I don't know why it's doing that. Okay, so here's my graph. I'm actually going to take a white pen real quick and just white out that side over there. And what we need to do is we need to figure out, well, what is the slope to calculate this? Well, if we plot the points A and B on the coordinate plane below, look at what we get. if we plot the point A, that's going to be -6, -1, -2, -3, -4, -5, -6, down 1, 2, 3, 4, 5. This point over here, that's point A. Point B is 4, 0. 1, 2, 3, 4, 0. That's point B. The slope of line AB is up 2 to the right 4, or the slope of 1/2. So if you go up 1 to the right 2, go up 1 to the right 2, go up 1, and you just keep on going, what I'm doing is I'm what's called partitioning of a line segment. Partitioning means that you split the line segment into parts, or that's called partitioning. So I'm now going to connect these points. Notice what we have here, folks. The ratio is 2 to 3. There are 1, 2, 3, 4, 5 segments inside the whole line. If this is a ratio of 2 to 3, and there's 5 of them, because 2 plus 3 is 5, and there's 5 segments, all you need to do is you need to count 2 segments and then leave the remaining 3. This point, this overlap that you see here, that's the point right there. That's point P, which is the point -2, -3. And that's how you do it graphically. All right? That's kind of a tricky question, not going to lie. All right, let's move on to question number 28. 28 says, in the diagram below, or the diagram below, shows a ramp connecting the ground to a loading platform 4.5 feet above the ground. The ramp measures 11.75 feet from the ground to the top of the loading platform. Determine, say, to the nearest degree, the angle of elevation formed by the ramp and the ground. Okay, lots of words. So, you're trying to find this, that angle measure right there. In order to find an angle, you have to use SOHCAHTOA. There's no other way to solve for an angle measure without using SOHCAHTOA. Okay? So I'm going to draw my little stick figure here. All right? And we need to talk about what these sides are. This is called a reference angle. Remember that. The reference angle is what you're referring to. This side, which is across from it, or it's called your opposite side. The side over here, it's not next, okay, it's next to it, but that's not your adjacent side. That's called your hypotenuse. Remember that the hypotenuse is always across from your right angle. So if we have O and an H, we are using sine, or so. So we are going to take the sine of the angle, and that is going to be equal to the opposite side over the hypotenuse. Now, I'm going to call this x. So we take the sine of x is equal to the opposite side, which is 4.5, over 11.75. Now, in order to solve for an angle, we need to take the inverse sine. That's that sine of -1 that you see. The inverse sine of 4.5 over 11.75. Now, make sure that your calculator is in degree mode. By the way, I use the TI Inspire CX calculator. It's an amazing calculator. I highly recommend it. Make sure that your calculator is in degree mode. If you forgot how to do that, you just go to Settings, Document Settings, make sure that your angle's in degree, click on Make Default, then click OK. I'm going to type in the inverse sine. The trig button is right up here, the trig button. I'm going to select inverse sine, and I'm going to type in 4.5 over 11.75, just like that, and you get 22.5. Round it to the nearest degree. That is approximately equal to 23 degrees, and you're done. Question number 29. In the diagram below of circle O, the area of the shaded sector AOC is 12 pi inches squared, and the length of OA is 6 inches. Determine and state the measure of angle AOC. Okay, well, you need to remember what the area of a sector formula is. The area of a sector is n over 360 pi r squared. Okay? They're telling you that the area of the sector, or the shaded piece, is 12 pi. So the big A is 12 pi. That's equal to n over 360 pi times the radius, which is 6 and squared. Remember, folks, we're trying to solve for this angle right here. We're trying to solve for that little red angle. Okay? We need to solve for n. So what I'm going to do is I'm just going to simplify this as much as I possibly can. So 12 pi is equal to 6 squared is 36. So that's 36 pi n in the numerator divided by 360. To solve for n, I'm going to multiply by the reciprocal, or just flip the fraction. So that's going to be 360 over 36 pi. And what you do to one side of the equation, you must do to the other side of the equation. So 360 over 36 pi. These cancel. No, I'm sorry. Only the right side cancels. This cancels with this, and you get n is equal to, now when you type this into your calculator, well, what do we get? 360 divided by 36 pi times 12 pi. And we get, I'm sorry, that's not the right answer. Why did it do that? Sorry, pi should be in the denominator. I don't know why that happened. Pi. 120. So the measure of angle n is 120 degrees. You're all done. All right. By the way, 120 degrees, if your teacher teaches you differently, this is also equivalent to 2 pi over 3. If you don't know what that means, forget about it. It is 120 degrees. But if you learned it this way, then that's fine. All right. Moving on to question 30. Question 30 says, after a reflection over a line, triangle A prime, B prime, C prime is the image of triangle ABC. Explain why triangle ABC is congruent to triangle A prime, B prime, C prime. Well, this is not a bad question at all. You need to know that a reflection is a rigid motion. So you're going to say that triangle ABC is congruent to triangle A prime, B prime, C prime because a reflection is a rigid motion which preserves distance and congruency. And that's all you need to say. Okay? That's why they're congruent. That would be acceptable. By the way, please do not say size and shape. Don't say that it keeps size and shape. Don't say that, because we are big boys and girls now. That would be considered incorrect on the Regents exam because that's not using mathematics vocabulary. Make sure that you specifically say preserves distance and congruency. Now, if your teacher told you size and shape, listen, that's fine. They might grade differently on the Regents. They're really not supposed to, but I looked at the scoring rubric and they really want distance and congruency as an answer choice. Okay? That's that. Question 31. A flagpole casts a shadow 16.60 meters long. Stop right there. Draw yourself a flagpole and a shadow. So I'm going to draw a flagpole, just like this. And I'm going to draw my little flag here. Here's my flag. Okay? It says little Timmy stands at a distance 12.45 meters from the base of the flagpole. So here's Tim over here. This over here is 16.60 meters long, and Tim stands at a distance of 12.45 meters from the flagpole. And his shadow touches this point. Perfect. And Tim is 1.65 meters tall. Great. It says determine and state the height of the flagpole to the nearest tenth of a meter. Well, this diagram is not helping me much, is it? Nope. Well, we need to figure out, what does Tim's height represent? Well, Tim could be drawn, and I know that this is pretty mean to say, but Tim could be a line. And what I'm going to do here is watch how I do this, folks. These two things here, these are I just created two similar triangles. I created two similar triangles. Tim is perpendicular to the ground. When you're standing, you're perpendicular to the ground. A flagpole should be perpendicular to the ground or else it's going to collapse. And notice here, folks, that this angle over here is reflexive in the big triangle and the small triangle. So I can conclude based off of that information that these two triangles are similar to each other. And if you know that these two triangles are similar, we could set them in proportion. Now, we need one more piece of information to figure this out. This right here. We don't have that because your goal is to take 1.65 and set it in proportion to this little side over here and set it in proportion to the x over the 16.60. A very common mistake that people make is they say, okay, let's do 1.65 over 12.45 equals 16.6 over x, or something on the lines of that. That's wrong. You need to find this length over here. Well, that's just going to be 16.60 minus 12.45. 16.60 minus 12.45. That's going to be a distance of 4.15 meters. So this little distance that you see over here is 4.15 meters. Okay. That's it right here. Now we could cross multiply. Perfect. So I'm going to cross multiply this number and this number. And I'm going to cross multiply this number and that letter. So we get 27.39 is equal to 4.15x divided by 4.15 on both sides. And you get x is equal to 6.6. Ladies and gentlemen, that is your answer. That is the height of the flagpole. All right. We are done with the part 2s. The part 2s are fairly simple. This is where the part 3s, these are more in depth and they require a lot of work and a lot of explanation. And please keep watching this video. I promise I'll go as quickly and thoroughly as possible, but it is going to take a while to explain this. So, part 3. Here we go. Question 32. In the diagram below, EF intersects AB and CD at G and H respectively, and GI is drawn such that GH is congruent to IH. So what I'm going to do first is I'm going to label that GH is congruent to IH. So that means just based off of the information that they gave me, this triangle that you see here, this is an isosceles triangle, because in an isosceles triangle, two sides are congruent to each other. Then it says here, if the measure of angle EGB up here is 50 degrees and the measure of angle DIG is 115 degrees, explain, oh God, there's that explanation again. Explain why line AB is parallel to line CD. All right, get ready to copy, folks. This is how much you have to explain this. This is how much you have to explain this. So I'm going to say in my answer, I'm going to say as usual, as shown above, EF intersects AB and CD at G and H respectively. So that's given to you, okay? And GH is congruent to IH. It's kind of like, this is really like making a statement reason proof in a form of a paragraph. I'm listing the given information first in order to prove why these two lines are parallel. So now I'm going to say, since these two sides are congruent to each other, meaning GH is congruent to IH, triangle GIH is isosceles, where angle HGI is congruent to angle HIG. And the reason why that is in an isosceles triangle, the opposite base angles are congruent to each other. And that will help us down the road. Believe me, I'm not saying this for no reason. Now, I'm going to say that since the measure of angle DIG is equal to 115 degrees, the measure of angle HIG is equal to 65 degrees because linear pairs are supplementary. Okay, now this is important. And remember that your goal is to really fill in all of these angle measurements. But this angle right here is 65 degrees because linear pairs are supplementary. That will help us. That will help us. Let's keep on going in our answer explanation. Now I'm going to say that this then leads to the conclusion that the measure of angle HGI is equal to 65 as well, due to the isosceles triangle theorem. Okay? Theorem. Okay. So if this angle is 65, then this angle up here is also 65. And again, we're trying to lead this to proof lines parallel. And I promise we're almost there. So now I'm going to say that the measure of angle GHI is equal to 50 degrees due to the triangle angle sum theorem. We're almost there. We're getting there. Triangle angle sum theorem. We're one step closer. So this angle over here is 50 degrees due to the triangle angle sum theorem. There's only 180 degrees in a triangle. You can't exceed 180 degrees or else it's not a triangle anymore. So now we're going to say that the measure of angle AGH is equal to 50 degrees because vertical angles are congruent. Now, vertical angles are congruent. This angle over here is 50 degrees. Wait a minute. Wait a minute. What are these right here? What are those? Now, I know it's a little dark, but that's a Z. Alternate interior angles are congruent. Ladies and gentlemen, that's what we've been trying to prove this whole time. Alternate interior angles are congruent. So now I'm going to say that AB, this is your final conclusion, AB is parallel to CD because a pair of alternate interior angles that are congruent form parallel lines. And that, ladies and gentlemen, is how you do that question. That's a lot of stuff. I don't even know if you can see that on your screen, but if you need to rewind it all, please rewind, be my guest, and go back and just copy whatever you need, or just to refresh your memory. All right. Moving on to a proof. Question 33 says, given quadrilateral ABCD is a parallelogram with diagonals AC and BD intersecting in E, we need to prove that triangle AED is congruent to triangle CEB. Nice. So I am going to right now create a statement reason proof. And just bear with me because I'm actually going to type this in. All right. So make sure that you set up a statement reason column because we need it to answer this question correctly. Let me shrink this a little bit. Nice. And that's bolded. Okay. So we have our statements. We have our reasons. Let me create a little T-chart here. And we're ready to rock and roll. Let me get out of here. There we go. Okay. So there are actually 4 ways to prove these two triangles congruent because it's a parallelogram. I personally like side angle side. So my plan to prove these two triangles congruent is side angle side. Why? Because AE is congruent to EC, DE is congruent to EB, and angle 1 is congruent to angle 2. I will explain all of that in the proof down below, but you could prove these two triangles by side, 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 angle, side, angle, and angle, angle, side as well. The only way that you cannot prove these two triangles congruent by is by hypotenuse leg because there's no right angle and never said that there's a right angle. And remember that you cannot prove two triangles by angle, side, side, which is ass, or AAA. You cannot prove triangles that way. So I'm going to say number 1. I'm going to say that quadrilateral ABCD is a parallelogram with diagonal AC and BD intersecting at E. I promise my handwriting will get better. The reason is given. That's all given to you. So now I'm going to say number 2. I'm going to say that AC and BD bisect each other at point E. And they do bisect each other because, remember, we are talking about a parallelogram here. These two diagonals bisect each other. So your reason is, in a parallelogram, diagonals bisect each other. Okay? Number 3, I am now going to say that, now since they're bisecting, we need to say that E is the midpoint. So E is the midpoint of AC and BD. Your reason is bisectors are drawn to its midpoint. All right. Let's keep on going. Number 4, now we're going to say that AE is congruent to EC and BE is congruent to ED. Your reason is a midpoint divides a segment into 2 congruent parts. All right, because E is a midpoint. Now, number 5, now we just proved 2 sides congruent. Now I'm going to say that angle 1 is congruent to angle 2. Your reason is vertical angles are congruent. And we are almost done. One more step. And we will call it quits for this question. Number 6, we're going to say that triangle AED is congruent to triangle CEB. And your reason is side angle side is congruent to side angle side. And that, ladies and gentlemen, is your proof on how to prove those 2 triangles to be congruent to each other. Now, there's a follow-up question. It says, describe a single rigid motion that would map triangle AED onto triangle CEB. So this here is going on to here. So what is that? That is showing a rotation. And the degree measure is 180 because that's a linear pair. So this is rotating 180 degrees. So when it says describe on the Regents, it needs to be a detailed description. You cannot just say rotation. That would give you no points on this question. You have to say that a rotation of 180 degrees CCW, which means counterclockwise, about point E, will map triangle AED onto triangle CEB. That is a detailed description, and that will give you full credit. All right, moving on to question 34. 34 is one of my favorite questions of all time. It really tests your knowledge on whether or not you know how to use right triangles. So it says here in the diagram below, a line of sight from the park ranger station P to the lifeguard chair L on the beach of a lake is perpendicular to the path joining the campground C and the first aid station F. The campground is 0.25 miles from the lifeguard chair. The straight paths from both the campground and the first aid station to the park ranger station are perpendicular. If the path from the park ranger station to the campground is 0.55 miles, determine its state to the nearest hundredth of a mile the distance between the park ranger station and the lifeguard chair. So we, ladies and gentlemen, are looking for this length right here. Okay, that's perfectly fine, because what do we have to the right of it? Hey, wait a minute. That's a right triangle. What could I use to find a side length of a right triangle if we're given 2 sides already? I hope that Pythagorean theorem is screaming in your head. So we are going to, I'm going to call this x. We are going to find x by using the Pythagorean theorem. Good old Pythagoras. And remember that the Pythagorean theorem is a squared plus b squared is equal to c squared. Here we go. So, this is your A, that's your B, I'm going to call that X though, and this is your C. So we have 0.25 squared plus B squared is equal to 0.55 squared. 0.25 squared is 0.0625 plus b squared is equal to 0.3025. I'm going to subtract 0.0625 on both sides. I then get b squared is equal to 0.24, and then you just take the square root of both sides, and you get b is approximately equal to 0.49, so I'm going to say that x is equal to 0.49 as my answer to the first part. Now, what's nice about this question is we're going to need that down the road because there's a follow-up question. And it says, Gerald believes the distance from the first aid station to the campground is at least 1.5 miles. Is Gerald's correct? Justify your answer. Now, real quick, I'm going to take a screenshot of this. I'm going to put it on the next page, so bear with me while I do this. Sorry if that just hurt your ears. I'm going to paste it over here. Okay, so here I have the same image, and it says here that Gerald believes that the distance from the first aid station, which is F, to the campground is at least 1.5 miles. So he's saying that from here to here is 1.5 miles or more. We need to find the length of FL to prove that. So how do we find the length of FL? And I hope that similar triangle proportions are also ringing in your head. We need to use this method right here. Now, I tell my students, I call this method the heartbeat method because it looks like a heartbeat. But your teacher might have taught it to you as the SAS method, which is segment over altitude equals altitude over segment. Or your teacher could have taught it to you as PAP, part over altitude equals altitude over part. Any one of these acronyms could be used to solve for this. So this is now your y value. We're trying to solve for the length of this using triangle proportions. But I call this the heartbeat method. So I call this your flat line, which is your y, over the pulse, which is 0.49, is equal to the pulse again, which is 0.49, over the flat line, which is 0.25. So you go flat line over pulse, you go up, and then you come down again, and you go to the right. Now we just cross multiply. So we get 0.25y is equal to 0.2401, and now we're going to divide by 0.25 on both sides, and we get y is equal to 0.96. Now, when we plug 0.96 back in, we now need to add these numbers. 0.96 plus 0.25, does that equal 1.5, or is it greater than 1.5? Well, no, it's 1.2. So we're going to say that Gerald is wrong. He is dead wrong because, and it says justify your answer, because 1.2 is less than 1.5. So Gerald is just a little bit too short. He probably forgot his triangle proportions. All right, that's question 34. On to 35. These are the part 4 questions. Almost there. The part 4 questions are so in-depth and it requires a lot of work. You really have to know what you're talking about. This is the famous water tower question. Everyone knows when they see this question that it came from the geometry reading. So let's read it through and let's figure out what we have to do. The water tower in the picture below is modeled by the two-dimensional figure beside it. The water tower is composed of a hemisphere, a cylinder, and a cone. Let C be the center of the hemisphere and let D be the center of the base of the cone. Now the question is saying on the next page, it says if AC is 8.5 feet, BF is 25 feet, and the measure of angle EFD is 47 degrees, determine and state to the nearest cubic foot the volume of the water tower. Volume of the water tower. So what I did for this question is I said, all right, I said here that this figure is a cone. This figure down here is my cylinder. This figure over here down below is a hemisphere. So what I did is I said, all right, I'm going to calculate the volume of each individual piece. So I'm first going to calculate the volume of the cone. I am then going to calculate the volume of the cylinder. And I am then going to calculate the volume of the hemisphere. Hemisphere. Now, we need some information from the diagram. So the volume of a cone is 1/3 pi r squared times the height. We got a problem, folks. We don't have a radius. No, I'm sorry, we do. We don't have the height of the cone. We need to solve for this. And I'm going to zoom in here. We need to solve for this height right over here. Okay? We need to solve for that. Our radius is 8.5. Every radius in this picture is 8.5. So we need to solve for the height. Well, how do we do that? We need to use trigonometry to solve for the height, because that's your reference angle, that's your opposite, that's your adjacent. Ladies and gentlemen, we are using the tangent. Tangent of 47 degrees is equal to the opposite, which is x, over the adjacent, which is 8.5. Okay? So now you cross multiply, and you get x is approximately equal to 9.115134. You need to keep this in the back of your brain because we are going to be using it again very, very shortly. So let's find the volume of the cone first. By the way, at the very end, we are adding all of these things. So the volume of the cone is equal to 1/3 pi times a radius of 8.5 squared times the height, which is what we just found, which is 9.11513. Please do yourself a favor. Do not round until the very end. Now, we're going to plug this into our calculator. Control division. Always use your fraction buttons. Control division. 1/3 pi times 8.5 squared times the height of 9.11513. Enter. We get 689.651. Remember, don't round until the very end. So 689.65125. Now, the volume of a cylinder is pi r squared times the height. Based on the diagram, the height is 25. Your radius is, again, 8.5. So volume is equal to pi times 8.5 squared times the height of 25. Let's plug that into our calculator so we get pi. I keep pressing I. Pi times 8.5 squared times the height of 25. And that will give you 5,674.50173. 5,674.50173. Okay. Now the volume of the hemisphere, that's V is equal to 1/2 of 4/3 pi r cubed. Where in the world did that 1/2 come from, Trevor? Because a sphere, the volume of a sphere is 4/3 pi r cubed. A hemisphere is 1/2 of a sphere. So we have to put that 1/2 out front in order to complete this portion of the problem. Now, the volume of the hemisphere is 1/2 times 4/3 pi times 8.5 raised to the third power. Let's go ahead and type it in. Control division, 1/2 in parentheses 4/3 times pi times 8.5 to the third. Who's bored yet? I am so sick and tired of doing this. 1,286.22039. 1,286.22039. Now, to get the volume of the whole thing, we have to... So, to find the volume of the whole tower, we need to add the cone, the cylinder, and the hemisphere. So, I am not going to do that by hand. I am going to type all these things into my calculator. Actually, if you arrow up and highlight it blue and you press enter, that actually copies and pastes things for you in this calculator. And I just keep going up, and I'm going to add everything that I need. And then I'm going to round at the very end. 7,650.37. It says round to the nearest cubic foot. Okay, so that's going to be 7,650 as your answer for the volume of the water tower. All right, cool. We're almost done with this question. So now it says, a follow-up question. It says, the water tower was constructed to hold a maximum of 400,000 pounds of water. Wow. If water weighs 62.4 pounds per cubic foot, Can the water tower be filled 85% of its volume and not exceed the weight limit? Justify your answer. So, folks, you need to know a formula, and you have to devote this to memory because it's on every single Regents exam. The formula is weight is equal to density times volume. Okay? Weight equals density times volume. We just found the volume, folks. It was back in the other part. The volume is 7,650. So we have our density, it's 62.4. We have the volume. So weight is equal to the density of 62.4 times the volume of 7,650. That will give us 477,360, what is that, pounds? Pounds. So this right here, this is the weight of the entire tower when it's filled. So that's the weight of the water of the whole tower. It says here, can it be filled 85% of its volume? Well, if we take this number, 477,360, and we multiply it by 85%, which is the same thing as 0.85. You have to express it as a decimal, and you learned that last year in Algebra 1. That will equal 405,756. Oh, that stinks, because that does exceed 400,000. So your conclusion is the water tower cannot be filled 85% because it exceeds the limit. And that is your conclusion. All right, so that's how you do that question. Not too bad, it's just a lot of work. All right, the very last question on this Regents exam. I hope that you're still with us. So question 36 says, in the coordinate plane, the vertices of triangle RST are 6, -1, 1, -4, and -5, 6. Prove that triangle RST is a right triangle. And the use of the set of axes below or on the next page is optional. So I always make a plan. I love plans. I got to make a plan because I am a little OCD. So the plan is, to prove it's a right triangle, you need to prove one right angle in the triangle. So I'm going to say, use the slope formula 2 times to show one pair of perpendicular sides. Now, since perpendicular lines form right angles, that could prove a right triangle. If there's one right angle in the triangle, the whole triangle is a right triangle. So I'm going to calculate the slope of ST, and I'm going to calculate the slope of RS. And the reason why is that if I were to show you on the graph on how this would look, if I plot S down here, so that's S, this is R over here, what is that, 6? 6 down 1, and T is -1, -2. What is point T? T is -5, -6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so this is my triangle. And as you could kind of look at it right now and see that it is perpendicular. So I'm going to calculate the slope of TS and SR and prove that they are negative reciprocal slopes. So the slope of ST, that's equal to the change in Y over the change in X, which is Y2 minus Y1 over X2 minus X1. That's your slope formula, folks. That is equal to 6 minus -4 over -5 minus 1, which is equal to -5/3. That's the slope of ST. Then we have to calculate the slope of RS, which is, again, your change in Y over... Sorry, those are ugly triangles. That is the change in Y over the change in X. That's going to be -4 minus -1 over 1 minus 6, which is equal to 3/5. Nice. So since those two are negative reciprocal slopes, then it is a right triangle. So I'm going to put a conclusion in somewhere. You just write this underneath. You need to say that RS and ST have negative reciprocal slopes. So RS is perpendicular to ST, so a right angle is formed. Therefore, triangle RST is a right triangle. Okay? You just have to write that conclusion in somewhere. Now there's a follow-up question, and it says here, state the coordinates of point P such that quadrilateral RSP is a rectangle. So I'm going to graph it. In a rectangle, opposite sides are parallel, and the adjacent sides are perpendicular. So the slope of TS, we just found out, is negative 5/3. The slope of the parallel line has to be negative 5/3 as well. But I'm going to go up 5 to the left 3. Up 5 to the left 3. I'm going to keep going until I see, ooh, that's a rectangle. So this point, that green point that you see, creates a rectangle for you. That coordinate is the point 0, 9. So I'm going to say down here, I'm going to say that point P has coordinates of 0, 9. And that will give you full credit for that part of the question. All right, we're almost done. And then it says, prove that your quadrilateral is a rectangle. So, in order to prove that it is a rectangle, this is your plan to prove that it's a rectangle. The plan to prove that it's a rectangle is you have to use slope 4 times on each side to prove perpendicular lines, because by definition, every single angle in a rectangle is a right angle. So we're going to calculate the slope of TP. So that is going to be, once again, the change in y over the change in x. That is going to be 6 minus 9 over negative 5 minus 0. That's equal to negative 3 over negative 5, which is equal to 3/5. You could get all these points, by the way, from the instructions. Now, oh, and P down here as well. So the slope of TS, well, we just concluded right before. We don't need to write it again. The slope of TS is negative 5/3. Now the slope of SR is going to be negative 4 minus negative 1 over 1 minus 6, which is equal to negative 3 over negative 5, which is equal to 5/3. No, I'm sorry. I just flipped that for some reason. I apologize. That's going to be 3/5. Okay? Now, we just calculated the slope of... we just calculated that before. Darn. Okay, so the slope of PR, that's going to be 9 minus negative 1 over 0 minus 6. That's going to be 10 over negative 6, which is equal to negative 5/3. So look at all these slopes, ladies and gentlemen. All of these slopes, they're all negative reciprocals. The 3/5 is a negative reciprocal of negative 5/3. 3/5 is a negative reciprocal of negative 5/3. So these adjacent sides, they're all perpendicular to each other. So you have to state a conclusion. So you have to say that quadrilateral RSTP is a rectangle because opposite sides are parallel and the adjacent sides are perpendicular, creating right angles. So if you have the same slope, that proves lines parallel, which means that the opposite sides are parallel. That's great. That's the property of a rectangle as well. And it does create right angles. And ladies and gentlemen, that is the conclusion of this Regents exam. I really hope that this helped you out. Please subscribe to my YouTube channel. There are so many math resources for you on this channel. There's so many more things coming and out there already. Please visit my website at www.nysmathregentsprep.com to view videos in a nice organized formatting, and there's a lot of helpful resources on there. All right, and I will see you soon.